This is the last question. The color of many corals is due to fluorescence proteins. Stony coral contain the protein P620, and when exposed to ultraviolet light, it glows with a particular bright color. People with aquariums that contain living coral use lamps that emit UV light to ensure that the coral is always colored. The partial energy level diagram for P620 is shown below. So this is the ground state, first excited state, second excited state. Calculate the wavelength of the ultraviolet light needed to cause this effect. So what you need to find how much energy required to excite any electron in ground state to E3. You must have this one, and how much wavelength is required. You need to find the difference in energy. Just take the absolute difference minus 0.55. Whole thing is actually EV. So you have a value of about 3.30 EV. And you need to find the wavelength. So this is the Hc over lambda. When you are using this equation, the energy you must change to joule. Okay, then only you substitute the H. You put in the speed of light over lambda. And the answer for here that you have is, according to my calculation, 3.76 to the minus 7 meter. So this is the answer for the ultraviolet light. And B, you have to calculate the wavelength of the emission line with the shorter wavelength, and hence determine the color of the coral under the UV light. Shorter wavelength. So you have to find the difference in energy. In this two state, E3 and E2 will be 1.50 EV. Here, E1, E2, 1.80 EV. Shorter wavelength means that you have more energy. So definitely we are referring to 1.80 EV. So with the same equation, E equals to Hc over lambda. Energy of the shorter wavelength is 1.80 EV. Change to joule. Substitute the H and C value. You must always do this. Don't skip. And the lambda, you have to find lambda. It is about 6.90 to the power minus 7 meter, approximately 960 nanometer. So if you want to judge what kind of color is it, it is more towards the red. Okay, it's nearer to this value. It's all red color. You cannot argue it with different color. So I want to conclude that it's a red color. Okay, so that's the solution. And then part C, many of the UV lamps sold aquarium owner have this, how to pronounce it, some coated safety cover designed to shield people from more dangerous form of UV radiation. Why is UV radiation considered harmful to human? You have to mention that the energy is, okay, you contain high energy here, and it can be ionizing radiation. It means they're very powerful. You can knock out the electron on your cell over here, and which can destroy cell and DNA. Okay, it can destroy cells, causing cancer, alter DNA, destroying DNA. So that's why this powerful is dangerous, more so for the X-ray and gamma ray. Okay, next, the following graph shows transmission property. At least 50% is needed for enough UV light to illuminate the coral in the aquarium. Determine the percentage transmission of particular UV that can cause stony coral to fluoresce, and hence explain whether or not this material will be suitable cover for aquarium lamp if the owner wanted stony coral to fluoresce. So this one you have to look back at your solution. Just now you found this value, the UV value to be 3.76 power minus 7. 376 nanometer. What you need to do, you need to interpolate this graph here. So I will presume the value may be here, the half of it as 380, and about half of it is here. So you have to use your ruler, do it slowly. I know this is difficult. Oh my goodness. Okay, so I have an answer here, which is crooked. If you use a ruler, I have a transmission percent. Transmission of 57% if I use my ruler, which is not clear over here, to answer whether it's suitable or not. Okay, so I would say that in this case it will be suitable because you can satisfy that it is more than 50% transmission. Okay, and this allows the coron to fluoresce. Yeah, so it is sufficient. So this will be the solution for this.